Today's lesson is going to be on reflections, and just as a reminder, if there's something that you do not understand, you can either send me an email or I can answer your questions when I come back. A reflection is also known as a flip, is a transformation in which a figure reflected in a line, called the line of reflection. A reflection creates a mirror image of the original figure. So you'll notice on this particular shape, the corresponding pieces are an equal distance away from the line. And it's flipped to a new position. So on your homework, you'll notice that there are a couple examples where you have to determine whether or not two shapes are a reflection. So you're going to check the distance away. And you also want to make sure that it is actually flipped over. So this one, you'll notice there's an equal distance away here, an equal distance away here, and it has been flipped over. So this one would be a yes. On the next one, you'll notice that there's a greater distance between the y-axis here than there is right here. And when you take a look at these two shapes, you'll notice that all we did with the red shape to the blue shape is slide it over to the right-hand side. That is the transformation that we learned about yesterday, called a translation. So the answer to that question is no, it is not a reflection because it's a translation. So go ahead and try these three on your own. Okay, so we'll check. We'll first look at number 1. Has the red shape been flipped over to the blue shape? The answer for this one is no. If you looked at it, you'll notice that all we did with the shape was slide it. No matter which direction we did, all we did was just slide it to a new position. This one would be called a translation. On number 2, you'll notice the exact same thing. All we did was slide the shape to a new position, so this one is also a translation. Both of those are translations. On number 3, it is flipped over. You can notice the equal distance between the parts. Here, this was on the bottom, now that became the top, and the top became the bottom. So any questions like this on your homework, all you have to do is put yes or no. If you want to be specific, you could give the type of transformation that's listed if it is not a reflection, but you do not have to. Okay, so as we go through these reflection rules, I'm going to go over the very first rule. Occasionally it's going to ask you to reflect a figure in the x-axis. When we reflect a figure in the x-axis, we want to actually take the opposite of the y-coordinate. Let me show you what that means. I'll show you on the graph, and I'll show you in terms of coordinate points. So we start out with the point 3, 2. You'll notice that there's a red point on 3, 2. I'm just going to make that a little bit bigger so we can see. And we want to reflect it across the x-axis. The first thing I would want to identify is what is the x-axis. Remember, the x is the smaller letter, so that's the one that lays down. I'm just going to highlight the x-axis right here. What I want to do is, since I want to flip it over, I want to see how far away that red dot is from the blue line. So it is 2 units away. Notice I'd have to go down 1, down 2 to get to that line. So if I want to reflect it, I want to go 2 away. Down 1, down 2, and I will make my new point. You'll notice that both the red and the blue point are 2 units away from the x-axis. So you'll notice I have 1, 2 spaces, and 1, 2 spaces. So because they are equal distance apart, I have now reflected it across the x-axis. So now we're going to take a peek at the coordinate point. The coordinate point of our blue point is positive 1, 2, 3 on the x-axis, negative 2. So what I want you to realize is exactly what happened between our points. So our original point was 3, positive 2, and when we reflected it over the x-axis, it became 3, negative 2. So the only thing that changed was our y coordinate. Rule number 2, to reflect a figure in the y-axis, we have to change the x coordinate. So our original point, we're going to start here. This time we're going to flip it across the y-axis. So I'm going to just highlight the y-axis. Remember, we said that the y stands tall, so that's the one that goes up and down. First, we want to figure out how far away is this point from our y-axis. Well, if I'm looking, it's 1, 2, 3 units away. So I'm going to have to go 1, 2, 3 units away in the opposite direction and make my point. So if I just want to do a little test, 1, 2, 3, and 1, 2, 3. They're both 3 units away. I'm going to list my new coordinate point. It is, from the origin, it's negative 1 to negative 3 up 2, so positive 2. So we want to just observe what happened here. Our original was positive 3, positive 2, and it became negative 3, positive 2. So the only thing to change here was our x-coordinate. So when we flip over the y-axis, our x changes. When we flip over the x-axis, our y-coordinate changes. Eventually, you should be able to just look at the coordinate points and see what exactly happened, and we'll be doing that by the end. Okay. So the directions for this next one say to reflect over the x-axis and list the new coordinates. So if this one's the x-axis, I've got to flip it over the x-axis, and I'll notice that it's 1 unit away, so I'm going to make it 1 unit away. They're equal distance across that line. So my original coordinate point was 3, positive 1. Since I flipped over the x-axis, my y has to change, and it should be 3, negative 1. It just became the opposite of what it was before. And I'm checking to see 1, 2, 3, negative 1. The next one, I'm going to reflect over the y-axis. So I'm going to highlight my y-axis. I'm going to check and see how far away it is. It's 1, 2 units away. So 1, 2 units away. Here is my new point. My original coordinate points were 2, positive 5. And now if I am flipping over the y-axis, that means my x has to change. So my x should become negative 2 while my y stays the same. If I check, negative 2, positive 1, 2, 3, 4, 5, and it works out. So again, just to reiterate this, when I reflected over my x-axis, it was my y variable that changed, or my y coordinate. And when I flipped over the y-axis, it was the x-coordinate that changed. So now we're going to be doing more than just one point. We're going to actually take a shape and reflect it across the axis. So I have to plot these points. It tells me that the vertices of a triangle are negative 1, 1. I'm going to go ahead and plot that. So from the origin, I have to go to the left 1 because that's negative 1, and then positive 1 means up 1. Negative 1, 1 is right here. I'm going to label that A. So now I'm going to label point B. Point B is going to be negative 1, positive 3. So from the origin, I'm going to go negative 1, up 1, 2, 3. I'm going to label that point B. And finally, I've got C, which is positive 6, positive 3. So I have to go positive 1, 2, 3, 4, 5, 6, and up 1, 2, 3. And that's point C. I'm going to go ahead and connect my 3 points. There we go. So there's my original shape. Now I'm going to read the rest of the directions, which tell me to draw the figure and its reflection in the x-axis. This means we have to flip it over the x-axis, which I just re-highlighted down here. Now, I want to take each individual point and put it an equal distance away from that x-axis. So I'm going to start with the A. The A was 1 above the line, so I'm going to come down and go 1 below the line, and I'm going to label that A prime. The coordinates of that, since I flipped over the x, the y value changed. So that is going to be -1, -1. Notice the only thing that changed from A to A prime was that this positive 1 became a -1. So now I'm going to go to point B. You'll notice that point B, I'm going to highlight it right here, is 1, 2, 3 units away from the line. So I'm going to go 1, 2, 3 units away and make a mark. Here is B prime. Now the only coordinate that should change should be my y. So I'm going to leave my x the same as -1, and I've got to do the opposite of positive 3, which is -3. If I check from the origin, I go to the left 1, -1, down 3. Down 1, down 2, down 3, which is -3. So now I'm going to label C prime. C is 1, 2, 3 units away. So I'm going to go 1, 2, 3 units away and make a mark. I'll label that C prime. I can go ahead and connect my lines. You'll notice that now it has been flipped over the x-axis. If I label point C, remember it's just the y that changes because I reflected over the x. So +6, -3. Now the directions are going to have us reflect across the y-axis. When we reflect across the y-axis, remember that the x is the one that changes this time. So I've got 1, 1. I'm going to go ahead and plot that. I have 1, 3, so 1, 1, 2, 3. And 6, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. So what I'm going to do is I'm going to just flip. This one's a little bit easier because we're flipping over the y-axis, and the A and the B are both equal distance away. So what I'm going to do is, since A is equal distance away, it's 1 unit away, I'm going to come over here, go 1 unit away. Label it A prime. The B is 1 unit away, so I'm going to go 1 unit away, label my B. And now my C, to get to the y-axis, is 1, 2, 3, 4, 5, 6 units away. 1, 2, 3, 4, 5, 6 units away. I can label my C and my B prime. Now I'm going to go ahead and connect. Now, when we reflect across the y-axis, it's the x that changes. So I'm going to highlight this. Just the x should change. So I can leave my y coordinate exactly how it was. So for A, it's going to be -1, +1. Remember, it's got to be the opposite here. For B, it should be -1, +3. And for C, it should be -6, +3. And when you go check, A is -1, +1. B is -1, +1, 2, 3. C is -1, 2, 3, 4, 5, 6, +1, 2, 3. So that's how we get our coordinate points. By now, you should be noticing the pattern with our coordinate points. So when we're looking at just these, you should be able to identify which axis we flipped over. Remember, if the x variable is the one that changed, you were flipped over the y axis. It's always going to be the opposite letter. So I want you to try this next one on your own. I'm going to give you a minute to go ahead and plot those 4 points. So you're going to start with -4, -3. Then you're going to plot -4, -1. Then you're going to plot -1, -1. And finally, you'll plot -1, -3. After you have plotted those points, it's asking you to reflect it across the x-axis. So stop and think. Which axis is the x-axis? Does the x stand tall or does the x lay down? If you want to check your points, A should be at -1, 2, 3, 4, -1, 2, 3. Here's A. B is -4, -1. C is -1, -1. And D is -1, -3. So I hope you had those points plotted correctly. Now we have to reflect across the x-axis. If you said that the x-axis was the one that laid down, you were correct. And now we have to figure out how to flip it over. The B is 1 unit away, so I'm going to come 1 unit away and label my B prime. The C is also 1 unit away, so I'm going to come up here and I'm going to label my C prime. D is 1, 2, 3 away, so 1, 2, 3. I'm going to come up here and I'll label my D prime. And A, I should be able to figure out where that goes based on the other points, but it's 3 units away. Okay, so now I'm going to write my points. Now, because I flipped over the x-axis, the y-coordinate should be the one that changes. So the y-coordinate is the one that changes. So the x stays the same, and the -3 becomes a +3. The x stays the same, the -1 becomes a +1. The x stays the same, the -1 becomes a +1. The x stays the same, the -3 becomes a +3. And I'm going to verify that those are the correct points. So -1, 2, 3, 4, 1, 2, 3. There's our A. So this one is good. -4, -1, 2, 3, 4, +1. That works. Then I go to the next one, -1, +1. -1, +1 takes us to C. And finally, -1, +1, 2, 3 takes us to D. So we are good on those last 2. The last thing that you'll notice on your homework is they are going to ask you to take a peek at coordinate points and tell whether they were flipped over the x-axis or the y-axis. So if the original was 3, -2, and then it became 3, +2, you want to check and see which coordinate changed. So you'll notice that the -2 became the +2. So since the y-coordinate was the one that changed, that means we reflected across the x-axis. Remember, it's always the opposite. The next one, you'll notice that our x-coordinate changed, which means we reflected across the y-axis. When our y value changed, we reflected across the x-axis. And when our y value changed again, we reflected across the x-axis. I'd like you to try the next 4 on your own. Remember, check to see which one changed. It's going to be the opposite for the reflection piece. So on the first one, which value changed? Did our x change or did our y change? You'll notice that our y changed, which means we reflected across the x-axis. On number 2, which one changed? You'll notice that the x changed, which means we reflected across the y-axis. On number 3, which one changed? The y value changed, which means we reflected across the x-axis. And finally, number 4, which one changed? Our x changed, which means we've reflected across the y-axis. If you have any questions, please email me, sullivana@milton.k12.wi.us.